Yeah. Now, see, guys, yesterday we got to know about yield method. Like we discussed about yield method, we discussed about concurrent hash map can be used in multiple threads. Okay, without doing any synchronization because it contains bucket level locks. We got no such kind of things in the last class. Okay, coming to today's session, first we'll understand about what are the two types of threads in Java. Okay, what are the two types of threads in Java? That's what we are going to discuss now. So let me open the document as well. Let's open the document as well. Okay, right. So in this document, last example is to know about how to use concurrent hash map in multiple threads. And also we discussed about what is yield method. Okay, these things I've explained in the last class. And also I told about how to join the two threads. These are the things I told in the last class. Now today we are going to discuss about, okay, we are going to look at about a concept called as the types of threads. Okay, we are going to discuss about types of threads. Okay, let's talk about types of threads, guys. Actually, threads are two types. Actually, threads are two types. One is user threads. Second one is a daemon threads. Guys, actually, threads are two types. Actually, threads are two types. Okay, one type of threads are called user threads. And the other type of threads are called as a daemon threads. Like that, we have two types of threads in Java. By default, every thread is user thread. Whatever the threads we create, they are all by default called as user threads. They are all by default called as user threads. Okay, they are all by default called as user threads. By default, all the threads that we create, by default, all the threads that we create are called user threads. Okay, right. Now, how can we identify that they are user threads? Suppose if it is a user thread, the program execution will continue. Okay, the main thread will be completed, or the execution of a program is terminated after all the user threads are executed. Which means, for example, main thread is there. Main thread execution is completed, but still main thread is waiting. Why? Because there is some user thread is running, and if the user thread is completed, then only the main thread is completed, which is nothing but program execution will be terminated. Even though main thread's task is completed, but still main thread is waiting for other thread to complete the work. Once it is completed, then the main thread will terminate the execution of the program. This is called as user thread. Okay, that is user thread. Because of user thread, main thread is waiting. Second kind of threads are called as the daemon threads. Second kind of threads are called as a daemon threads. Okay. If it is a daemon thread, we will make the thread as a daemon thread. I'll tell you how to make it as a daemon thread. If I make a thread as daemon thread, then main thread will not wait until the daemon thread's execution is completed. When the main thread's work is completed, task is completed, main thread will terminate the program execution automatically. The daemon threads, whichever is running in the application, they are also gets terminated. But main thread will not wait. That is called a daemon thread. But by default, threads are not daemon threads. We call them as user threads. So to understand this concept, before I write my statements here, let me show you the two things. For example, okay. For example, I will do one thing. Let me create a new Java project. Let's say in this project name, I want to take it as a daemon thread. Already I have daemon thread example, so I don't want to write. So there is a project I have with me called a daemon thread demo. I have a project called as a daemon thread demo. Okay. Look at this. Because this is written in Java 8 format, I will convert it into before Java 8, how to create class mythread1. Extends thread. Another way is what implements runnable. I told in the last which is the best way of creating the thread. The best way of creating the thread is what? By implementing runnable interface. The best way of creating a thread is by implementing runnable interface. There are two ways of creating a thread: extends thread and implements runnable. But the best way is implements runnable. Of course, we are writing extends thread, but implementing runnable is the best way, because if you implement runnable, still your class can extend one more base class, parent class. If your class is already extending thread, your class cannot extend another parent class. That's why implementing runnable is the best way than extending thread class. Now we'll go ahead. I want to define a task like this. This is the for loop. This is one task. I repeat it. Now I want to create what? One more thread class. How can I create one more thread class? Class mythread2 extends thread. Okay, yes. Again, here also we should override a method called run method. The task in run method is print the J value. Done. Everybody, just try to understand. I am creating two thread objects here. I'm going to create two thread objects. mythread1, T1 is equal to new mythread. Okay. Then guys, I'm creating one more object, mythread2, T2 is equal to new mythread. mythread1, mythread2. Correct. Okay, guys. mythread1, T1 is equal to new mythread. mythread1. First object, second object. See, first thread is printing 1 to 50. Second thread is printing 1 to 10. Correct? 1 to 10. Let's do one thing. Instead of creating second thread, we will print 1 to 10 in main thread. Better, so that you'll understand. I'll do one thing. I will do one thing, guys. I want to change my code. What I will do is, please understand. I want to remove my thread too. I want to remove this class. Now tell me how many threads are there in my application first. There are 2 threads. Main is already a thread, which is called main thread. And one more thread is created. So totally there are 2 threads. Here, main thread is going to display the values from 1 to 10. 1 to 10. This other thread is going to print the values from 1 to 50. 50, 1 to 50. Question is, if I run this program, main thread task is display the values from 1 to 10. But even though main thread work is completed, but still main thread is waiting, because this is a user thread. By default, this thread is called what? User thread. It's printing the values from 1 to 50. Until the thread execution is completed, main thread is waiting. After 1 to 50 is completed, then main thread will terminate the program execution. Which means what? Let's take 1 to 30 instead of 50. 50 which will take some time, 30. 1 to 30. Okay. Look at this case. By default, whenever we create a thread object, it is going to become like what type of thread? User thread. User thread. Okay. Tell me, main thread is going to display the values from what? 1 to 10. My thread is going to display the values from 1 to 30. Main thread task is completed first, but still main thread is waiting for what? To complete this user thread. To complete this user thread. Once user thread is completed, then will terminate the program execution. Main thread will terminate the program execution. If you want to know about this, let's give the names. Already we know that how to set the name. T1 dot set name of user thread. Just I'm writing the name as user thread. And how to set the name for main thread as main thread? I can write thread dot. How can you get the reference of current thread in main? Thread dot current thread dot set name of main thread. If you want to get the reference of a current thread, we have to call a method called what? Thread dot current thread. Current thread method to call. Then call what? Set name method. Pass what? The name. Okay. Now this is T1 dot set name of user thread. Now I wanted SOP statement saying that system dot out dot println either above or below, wherever it is. I'll write here system dot out dot println inside thread dot current thread dot get name. Set name, get name methods, How can you get the reference of a current thread in a class? By calling this method called current thread method. When you are in a thread class, main is also a thread class. Inside a thread class, how can you get the reference of the current thread? How can you get the reference of a current thread in a thread class? By calling current thread method. So who is the current thread here? If I'm writing thread dot current thread, for example, then who is the current thread here? Main thread. Main thread is a current thread because this main method is inside main class. Now this is called what thread? Main thread. Okay. What the name of the main thread is main, M-A-I-N. But I want to set the name as what? Main thread. That's why I'm calling set name method. Okay. Now after this for loop is done, system dot out dot println thread dot current thread dot get name is finished. So what is the statement you will get here? Inside main thread. Current thread is main. Here what you will get? Main thread is finished. Similarly, I'll go to this run method. Now, inside this run method, I want write what? In run method, I can call what? Thread dot inside which thread? Current thread. How to get the reference of current thread? Current thread method. Dot. How to get the name of the current thread? Get name method. That's it. Now tell me here, if I call thread dot current thread, who is the current thread here? It's not main thread. It is what? My thread one. What the name? What is the name given to my thread one object? User thread. So what the name I will get here? User thread. Inside user thread. After the for loop is completed, guys, after the for loop is completed, I will write my statement what? System.out.println. You know what? Thread dot current thread dot get name is finished. That's all. Okay, now? So always remember, whenever you call the current thread method, what will you get? You will get the current thread reference. What you will get? You will get the current thread reference. If you are writing this statement in my thread one class, you will get the my thread one class reference. If you are writing this statement in the main class, you will get the main thread reference. Wherever you write that thread reference. How can you get the reference? By calling this method. Which method? Current thread dot current thread. Correct. Next. Let's go ahead and understand it. Okay, let's see. Inside main thread, inside user thread. So who is printing J value? Main thread. Who is printing I value? User thread. Okay. Main thread prints up to 10. J value 10. See, main thread is finished. But still, user thread is going on. But still, program execution is going on. Means what? Program execution is not terminated. Why? Because user thread is working. When the execution gets terminated, after the user thread execution is completed. If there are 2 user threads, after the 2 user threads are completed, like that. We can see what thread is finished? User thread. Now you tell me, we got a message called what? Terminated here. You got a message called program terminated. Correct. Okay. You got a message called terminated, guys. Correct. So this is called what type of thread? User thread. So let me write this point. I will write this point first. For the point, by default, all the threads that we create are called user threads. Okay. So what I can say is, I can write the point like this. I'm just thinking about how to start the point with the main thread or with the task. Okay, let me write any point, but if you understand, that's enough for me. The point what I want to write is main thread. Okay, main thread will not terminate the program execution, will not terminate the program execution until until all the user threads until all the user threads are completed. Main thread will not terminate the program execution until all the user threads are completed. Okay, right. Look at the same. Look at the same. Now I want to do one thing. Before I start this, I want to make it as a daemon thread. For that, we have a method called set daemon true. There is a method called what? Set daemon true. Now this makes what? A thread as a daemon thread. It's a daemon thread. If you make it as a daemon thread, then main thread will not wait until the daemon thread execution is completed. When the main thread execution is completed, automatically daemon thread is also terminated. That type of thread is called what? Daemon thread. Mostly we use the daemon threads for background process. Okay, if any background work is there, daemon thread will do the background work. And whenever the program execution is terminated, main thread is terminated, automatically background work is also terminated. So to perform any background works, like application monitoring, garbage collections, those kind of things will define in daemon threads. Here, what the important point you should know is how to make a thread as a daemon thread by calling what? Set daemon true. Okay, now I want to change the name. Instead of calling it as user thread, what name I want to set for this? Daemon thread. For example, I want to change the name like daemon thread because I'm calling this method. Which method I'm calling? Set daemon. I'm passing what? True. Okay. Now what I want to do? Guys, I want to run this program. Now check it. See the difference between last example output and this example output. Okay. Inside main thread, inside daemon thread. Or you can say main thread is printing, daemon thread is printing, like that you can just display. When j is 10, when j becomes 10, what happens? When j becomes 10, main thread is finished. Then tell me automatically what happened? Program execution also terminated. But what about daemon thread? It is actually has to print what? 1 to 30. 1 to 30. But it has printed up to 11 only. But what happened automatically? Program execution is terminated. Because main thread is finished now. That type of thread is called what? If it is a user thread, okay, program execution is not terminated. Main thread will wait until user thread is completed. That's the difference between user thread and daemon thread. Guys, am I clear with you now? Everybody, am I clear with you? Did you understand the concept? How to make a thread as daemon thread by calling this method called set daemon true. Whenever you call a method set daemon true, the thread will become which thread? Daemon thread. If you don't call set daemon true, if you don't call this method set daemon, and if you don't pass the value true, then tell me this thread will become by default what thread? User thread. Okay, these are the two types of threads we have in Java. These are the two types of threads we have in Java. Okay, now guys, I want to write the point here. Okay. To make a thread as a daemon thread, to make a thread as daemon thread, call set daemon of true on the thread object. Which method to call? Set daemon true on the thread object. When, if you want to make a thread as what thread? Daemon thread, call set daemon of true on the thread object. That's the thing what you have to do. If you make a thread as daemon thread, what happens now? So guys, if you make a thread as daemon thread, what happens now? Main thread will not wait for the completion of daemon thread. Whenever the main thread execution is a task is completed, whenever the main thread task is completed, the program execution will be terminated. Execution will be terminated. Okay. Make it as 3 or 2 something. Guys, am I clear with you? Whenever the main thread task is completed, the program execution will be terminated. That's how daemon threads work. Okay. So daemon threads are mostly used to perform background works. Background works means like memory related works. Otherwise, application monitoring works, or in real time, we have some kind of log statements monitoring the application logs. These kind of background things we will define in a daemon thread. So mostly daemon threads are used to perform background operations. Daemon threads are created to perform background operations. Whenever the application is terminated, automatically daemon threads are also terminated. Okay. But main thread will not wait for completion of daemon thread. If a main thread is completed, automatically program execution is terminated such that daemon threads are also completed. If it is a user thread, then main thread will wait until that user thread is completed. After that, program will be terminated. That's the difference between user thread and daemon thread. Okay, I'm just copying this program, but at the time of executing this, today how I have executed, you also execute 2 times. How I have executed, you also execute this program for 2 times. One time, make the thread as user thread. Other time, make the thread as daemon thread. Okay, and do the work. Okay, do the work. This is the concept of daemon threads. Now, now we need to understand an important concept called as threads synchronization or thread synchronization. This is an important point. I mean, you should know about what is synchronization and how we can do that. All these things we are going to discuss today. So basically, this is an important concept in multi-threading. You should understand about a concept called as what is threads synchronization. Okay, observe here. Just give me a second, I'll come back. Yeah, yes, we'll start now. Now we will understand about, okay. Now we'll understand about a concept called as what is thread synchronization. Synchronization is a somewhat in multi-threading. This is the important concept that you have to learn. First of all, we have to understand that two threads can share, or two threads can utilize any word I can just say. Two threads can share the same object. Okay. You have to understand synchronization. Next, after this, you need to understand about deadlock. These are the two important concepts in threads that you should know. First thing is, through two threads can share same resource. For example, yesterday, I have created one concurrent hash map object. Resource means object. Two threads can share same resource. It's meaning two threads can use same object. Resource means object. Yesterday, we have created one concurrent hash map object. Concurrent hash map object we created. Yesterday, we have created concurrent hash map object. And you know, this concurrent hash map object, we shared it with my thread one and main thread. Yesterday, we discussed example like this, which I mean, the same object is used in two threads. Object is one, but used in two threads, which means basically what you are understanding that we can able to share same resource to multiple threads. Correct? Nothing but now, this is called shared resource of multiple threads. Now, when there is a shared resource, of course, I took concurrent hash map. I'll delete this diagram. This is what yesterday we discussed. Today, what I am trying to say, that and delete this. What I am trying to say that when two threads are sharing when two threads are sharing the same resource, when two threads are sharing the same resource, okay, right? I repeat once again. When two threads are sharing same resource, and if one thread has modified that resource, if one thread has done some changes in the resource, okay, if one thread has modified the resource or changed the resource, whatever it is, if one thread has modified the resource, the changes whatever is made by the thread, okay, the changes whatever are made by the thread will also reflect on other thread, because both are sharing same resource. Both are sharing same resource. Let's take example to understand that. So which I'm trying to say is what? When two threads are sharing the same resource, second point, when one thread makes changes, before those changes are affected, before those changes are affected, or before those changes are updated, if other thread is also, before those changes are updated in the resource, if the other thread is also, if other thread also accessing that resource, okay, then we will get inconsistency in our application. How? Let's take up an example. For example, this example we will implement in our program also. The thing is what, when one thread is performing a task, and when the thread is performing a task to update the resource, before it has updated or before the changes are affected, if other thread is also trying to access the same resource, then we will get inconsistency in application. So in order to avoid inconsistency, when multiple threads are sharing the same resource, we will apply a concept called as thread synchronization. So how it is? Let's see. Let's see with an example. I take up an example. I will take up an example and I will try to explain the example. Okay, I'll take up an example and I'll try to explain the example. Observe here. See, for example, this is one course object. This is course object. This course object contains course name, seats available. I'm writing simply SA means seats available. Suppose course name CSE, available seats 1. This is course object. There are 2 threads now. Let's say, for example, this is registration thread 1, RT1. This is the registration thread 2, RT2. Correct. There are 2 threads, RT1 and RT2. Okay. Understand, when RT1 and RT2. Actually, 2 threads are sharing this resource. Two threads are what? Sharing this resource. For the resource here, course. It is an object, course object. It's a resource. Resource means object. 2 threads are sharing. 2 threads are, one is a registration thread 1, other one is a registration thread 2. Actually, what happened is registration thread 1 wants to register the seat in this course. First, it is trying to access what? How many seats are available in this course? How many seats are available means 1. Now this registration thread wants to book that seat. And now it wants to update the seats available 0. Now what happened? Registration thread 1, it's first, it is going to check how many seats available. 1. In the course, 1 seat is available. It will book the seat. It will register the seat. If the seat registered, it's going to update the available seats to 0 now. But what happened before this registration? Before the registration thread updated the seats to 0, another registration thread is also working on the same course object. It is getting the available seat value. For the available seats 1. Actually, this registration thread 1 is trying to update the seats available as what? 0. But before it is updated, another registration thread, what happened? It is getting the available seats. How many seats is available now? 1. Registration thread also will book that seat. This is called inconsistency, which is nothing but what? Same seat, only one seat available. Same seat is registered for student 1 and also for student 2. This is called inconsistency. This should not happen. This should not happen. That's what requirement. Okay, when this will happen? If two threads are sharing on same resource, and if one thread is modifying the resource, but before the modification is affected, if other thread is trying to access the data, then what kind of, when two threads are accessing the same resource, okay, and before the changes of one thread are going to affect, if other thread is trying to access the data, then we'll get what type of problem here? Inconsistency problem. Because if when there is only one seat available, for how many students this seat can be booked? Only for one student. But what is happening here? That seat is booked for two students. Two threads feel like two students. Now tell me what happened. The same seat is booked for two students. This is called inconsistency. So to avoid this inconsistency, what we do is we apply a concept called synchronization. What happens in synchronization? If, for example, two threads are sharing same resource, two threads are sharing same resource, correct? Same resource. Two threads are sharing the same resource, correct? What happens now? If one thread is performing a task, one thread is performing a task. If one thread is performing a task, correct? Then don't allow other thread to access it. If this thread is trying to book the seat, then don't allow second thread to book the seat. Wait. Tell me, if thread 1 has booked the seat, it is updating the seats to what? 0. Now you allow second thread, because thread 1 task is completed now. Now allow the thread 2 to perform the task on that resource. When thread 2 is trying to perform task on this resource, tell me how many seats available it will get now? 0. By seeing 0, what you'll understand? No seats are available. The what thread 2 will display a message to the student. Sorry, seats are filled. No seat is available. This is consistency. This concept is called what? Synchronization. This concept name is called what? Synchronization. Okay. This is actually a very important concept. The concept name is called what? Threads synchronization. Threads synchronization. Am I clear with you guys? Okay. So the thing is what? See here. See, if multiple threads are executing the same task simultaneously with a shared resource means what? Shared resource means what? One object shared by multiple threads. That is called shared resource. Yesterday, concurrent hash map object is one resource, but it is shared between main thread and other thread. That is called what type of resource? Shared resource. Now in my example, I have one course object. That same object we are sharing with thread 1 and thread 2. That is called what resource? Shared resource means shared object. If multiple threads are executing the same task simultaneously with a shared resource, and if one thread access the data before other thread has updated it, we will get what type of results? Invalid results. Are you getting my point? Then we call this concept name as inconsistency. Then we call this concept name as what? Inconsistency. Am I right? We call this concept name as what? Inconsistency. If multiple threads are executing the same task simultaneously with a shared resource, and if one thread accesses the data before other thread has updated it, then we'll get what? Invalid results. This is called inconsistency. This is called inconsistency. Inconsistency. Correct. For example, if there is a course with only one seat available and two student threads are registering for the same course at a time, then if two students are allowed to book the seat, then we'll get what? Invalid results. Invalid results is nothing but inconsistency. To overcome this problem, we apply what concept? Synchronization. What that synchronization will do? Allows only one thread at a time to execute a task on a shared resource. If one thread is executing the task, then other threads have to wait for the completion of the thread. Every object has a lock. I'll explain that, which is also called as monitor, which means if thread 1 is using that course object, for example, if thread 1 is using the course, what about thread 2 has to wait because that object has a lock. Now that lock is with thread 1. What is the meaning of synchronization? A thread will acquire lock on a resource. Every resource has a lock. Resource means object. Every object has a lock. If a thread 1 has got the lock, okay, which means what? Thread 1 is allowed to work on that resource. What happens if thread 1 completes? It will release the lock so that other thread can get the lock. Every object has a lock. So how many threads can acquire that lock? Only one. Only one.
One at a time.
Okay, only one at a time. Only one. So if one thread has already acquired the lock, other thread has to wait. How much time? Until that thread releases the lock. Until the thread releases the lock. If the thread releases the lock, other thread can acquire it. Like this, how many threads are allowed to perform a task on the shared resource now? Only one.
At a time,
one after the other. At a time, one. One after the other. At a time, only one can do that, not multiple. This concept name is called what? Thread synchronization. Okay, right. A thread holds the lock and executes a task on that object. Other threads will wait for the lock to be released by the thread. A thread can acquire or hold a lock on an object when it starts executing a synchronized method or synchronized block. I'll tell you what is this meaning. For that, we have a keyword called what keyword? Synchronized keyword. Okay, that can be used with for methods and blocks. We'll understand. This I will explain, but this is all theoretical points which are related to synchronization. Instead of typing them again, I just want to copy into our document. That's why I opened it. That's why I opened it. Okay, come to the point again. I'll explain. Observe here. To let's say to understand to understand this synchronizations in a small shorter way, let us take another example to understand it. Let's do one thing. I will take another simple example to understand how synchronization works. Let's take okay. Let's check, guys. Simple example. Please understand. There is a variable called X. Simple variable X. A resource is my variable. Current X value is 10. X value is how much now? 10. Current X value 10. Please understand. X value 10. There is a method called as increment. There is a method called what? Increment. Increment is one method we have. Increment is a method. X is equal to X plus 1. Assume that X is equal to X plus 1. Now the question is, two threads are executing this instruction at a time. How many threads are executing? Two threads. T1 is a thread. T2 is a thread. Two threads are executing this method simultaneously. Two threads are executing this method simultaneously. What this method will do, will increment X value by 1. Correct? Everybody? Two threads are executing this method at a time. Understand clearly. Question is, if two threads are at a time executing this method, simultaneously they are executing this method. Correct? For example, try to understand me now. For example, get it clearly. I mean, understand the concept now. I'm taking simple example to understand. Two threads are executing this method or this instruction at a time. Now tell me, if a thread 1 prints X value, okay, thread 1, if a thread 1 prints X, can you tell me what the value of X? Similarly, if thread 2 prints X value, T2 prints X value, can you tell me what the value of X?
11, 12.
11, 12. See how many threads are simultaneously executing this method, increment method? Two threads. Okay, two threads. Tell me what the value of X. If T1 prints X value, what the X
10.
value? If T2 prints X value is how much?
X value is 10.
Sorry.
11 both.
Okay. Next, any other answer?
11, 12.
10, 11.
11, 11. Any other answer?
11, 12.
10.
11, 12. Okay. Question
10,
is,
11.
how it is 10, 11? Okay. See the answer. First, I want to explain. Tell me how many threads are calling this increment method?
2.
Two threads are executing
Two
this method.
threads.
Which method? Increment method is executed by two threads. T1 and T2, two threads are there. I have a question. I have a question. Question is, I want to tell you one thing. Please understand me. Suppose T1, T2, two threads are executing. Question is, which thread will get the first chance?
T1.
Who told you? Who told you that T1
Based
will
on
get
the
the first
T1.
chance? I told it all depends on thread scheduler. Correct?
Yes.
It all depends
Yes.
on scheduler. Scheduler may pick up T1 or may pick up T2. Correct?
Yes.
It may pick
Yes,
up
sir.
T1 or it may pick up T2. That we don't know. Suppose if T1 is picked up first, then T1 will execute instruction X is equal to X plus 1.
11.
Correct?
10 plus
11.
1, 11.
11. After T1, if T2 get the chance, then T2 executes X is equal to X plus 1. What's the answer?
12.
12. Because already X is updated now.
Yes.
12.
Yes.
11, 12. But if T2 get the first chance,
It will
11.
depend.
T2 will
if
become
T2 get the
11.
first chance,
and
result
T1.
will be 11.
Yes.
Yes.
Next for T2, T1 it is 12.
Yes.
Am I right? I
Yes,
mean to
sir.
say what? I mean to say what? When T1, T2, both the threads are working on the same resource, we can't predict the exact result.
Yes.
That's why we apply the concept of what? Synchronization.
Synchronized.
Yeah. For example, try to understand. For example, if I make this method as a synchronized method, then how many threads are allowed at a time?
1.
1.
1 thread
Only
at a
one.
time.
So T1 has entered, then what about T2?
Not
It
entered.
should wait.
It should wait.
It is in waiting state.
It is in waiting state. If T1 has entered, T2 is in waiting state. If T2 enters, T1 is in
T1 waiting state.
Means at a time, how many threads can perform this
1.
increment operation?
1 thread.
One
1
thread
thread.
can perform. Only one thread can perform operation. If only one thread is performing the operation at a time, then we can get consistency. If multiple threads are working on the same resource, right? And if one thread is trying to access the data before other thread has updated the data, we'll get inconsistency. To avoid this inconsistency, we are going to apply a concept called what?
Synchronization.
Synchronization. For that, which keyword we have to use?
Synchronized.
Synchronized.
By using synchronized keyword, by using which keyword? Synchronized
Synchronized.
keyword. Synchronized keyword. We can use methods and blocks. I mean, we can create methods and blocks. We have synchronized methods and synchronized blocks.
Blocks.
Both are there. Let's start with. Let's try to understand the example. See here. First, I will remove synchronization. You just understand the example. I'll remove synchronization. First, I'll remove synchronization. Then later again, I'll apply synchronization. Just understand, I'll tell you. Because this we have not yet discussed. I'm going to create a thread class. I'll pass the course object as a parameter. Just wait. Class register thread extends thread. And I want to take constructor with course object as a parameter. Okay, I just want to override run method. In the run method, I just want to call. In the run method, I just want to call. Here I want roll number, so I'll pass. Okay, no problem. Enter roll number. Don't worry, I'll explain. I'll explain the program. You just wait. This dot roll number is equal to roll number. Constructor. Here I will call course dot register for course of roll number. Observe here. I have a class called course. I'll create the threads later. First, I'll explain. Okay. You know, when we need to apply synchronization, if multiple threads are working on shared resource or same resource, okay, then one thread made changes may affect on other thread, or one thread has modified the changes, but before the changes are affected, if other thread is reading the data, access the data, then also inconsistency problem will occur. To overcome these problems, we need to apply a concept called synchronization. Okay. First, understand here, everybody. I have created one class called as course with the two variables. What are the two variables? Course name, number of seats available. Two variables are there in my course class. Two variables. Course name, number of seats available. This is constructor. You are aware of constructor. Constructor will initialize the data members. Correct? Now there is a method called what? Register for course. Okay. Please understand now. Pass the rule number. If number of seats available -1 less than 0, then I want to throw exception. What's the exception? Sorry, seats are not available. Your roll number is so and so. Suppose if exception is not thrown, suppose if exception is not thrown, then what the message? Booking successful. Your roll number is so and so. Decrement the seats by 1. Because booking successful means 1 seat is booked. Decrement the number of seats available by 1.
Yes.
Now display how many available seats are there. Correct?
Yes.
This is what I want to do. If exception occurs, just display that message, error message. Am I clear?
Yes.
What's the method name? Register for course.
Register for course.
This is one class course. It has a method called register for course. Here I am creating course object. What the course name? CSE. Number of seats available? 1.
1.
Now I created one thread also. One thread class. I created one class, thread class. It has a constructor with 2 parameters. It will accept a course parameter and roll number parameter. And in the run method of thread, I am calling which method? Register for course. Okay, right? My question to you. If I create 2 objects of this thread class, 2 objects. How I create 2 objects? A register thread is a thread class. For this thread class, T1 is object is equal to new. register thread. But to the constructor of register thread, I have to pass two parameters. What are the two parameters? Course, comma, rule number. For the course object, here I have course. In main method, I created one course object. Now I'll pass course object, comma, rule number 101. Tell me how to create one more object, one more thread object for the same thread class. Register thread T2
T2 equal to new register
equal
thread.
to new register thread of course, comma, 102. Tell me guys, how many threads I have created?
2.
Two threads. What are they? T1 and
101.
T2. Two threads, not T1 and T2. Two threads I have created. Okay. You know, when T1 is executing, run method is called. In the running state, run method only called. Na?
Yes.
When T2 thread is executing, again run method only called.
Yes.
Now tell me, from the run method, we are calling which method of course? Register for course. Correct? Suppose, assume that first chance came to T1. Assume that first chance came to T1. Assume that. Which thread has got the first chance? T1 has
T1.
got the first chance. Tell me, T1 call this method now.
Yes.
From the run method, we are calling register for course method only now. When this
Yes.
method is executing now. Which thread
Yes.
is executing this method now?
T1.
From T1, we are executing this method. Yeah, T1 has entered. Because first chance came to T1 now. T1 will execute for some milliseconds of time. Some time slice will be there. Maybe 100 milliseconds or 10 milliseconds, depends. T1 entered. T1 entered. T1 is going on. T1 is next went to inside the method. There is a try block. Then entered into if statement. Okay. For the if statement, number of seats available -1 less than 0. For the number of seats available initially 1. 1 minus 1, 0.
0.
0 less than 0, false. False means control comes out. Comes out. Next, control entered into SOP statement. Okay. Tell me what's the message printed. Booking success.
Booking successful.
Now what happened, T1's time is over now. Suddenly. Because it has some milliseconds of time now. Next, who got the chance? T2.
T2.
Yeah. Now, green color. Green color is T2. Now tell me who entered into this. Which thread has got the chance to work?
T2.
Now tell me, T2 thread also calling the register for course.
Yes.
Okay. Now T2 entered. T2 also entered into try. Entered into if. Tell me, what are the seats available? 1.
1.
1 minus 1, 0. 0
0.
less than 0,
False.
false. Comes out. Next, T2 enters into SOP statement. For the message,
Booking
Booking
successful.
successful. Now T2's time is over. Whose time is over? T2's
T2.
time is over. Then T1 will get the chance now. Some 10
Yes.
milliseconds or something. T1 got it. T1 will start now. Now T1 will start with red color. From this point now, from this statement now, because already it has executed after SOP. Number of seats available minus equal to 1. How much number of available seats now?
1.
1 minus 1. 0.
0.
0. It prints what message?
Seat available.
Available seats
seat.
now is 0. T1 work is over. T1 completed. T2 entered. T1's time is over now. T2 enters. T2 also will start from this place only now. Previously it is good up to SOP. For the number of seats available now? 0 minus 1. Already 0 is updated now. 0
Yes.
minus 1 equal to minus 1 now. Now tell me it
Yes.
prints what? Available seats now. How much? Minus 1.
minus 1.
Are you able to follow me? I have a question to you.
Yes.
How many seats actually available in the course? 1.
1.
But how many times you got booking successful?
2.
2 times. Which is nothing but what?
Inconsistency.
one seat is booked for student 1 and student 2. This is called inconsistency. Able to follow me now?
Yes.
That's why if a T1 has entered into this method, let me use red color. If a T1 has entered into this method, until T1 completes it, we don't want to allow what? T2,
T2.
correct?
Yes.
We don't want to allow T2. If a T1 completes entire method, then tell me it will update the number of seats available is equal to 1 minus 1, 0. Na?
Yes.
Next, when T2 enters, available seats will be how much here?
0.
0. 0 minus 1 is minus 1. Minus 1 less than 0.
0.
Throw what? Exception.
Sorry,
For
seats.
T2, what message comes? Sorry,
Seats
are
are not
not available. This is
available.
called consistent behavior. Na?
Yes.
For that, I need to apply what concept?
Synchronize.
Synchronization. How can I apply synchronization? To allow only one thread to operate on a shared resource, right? I need to make that method as synchronized method. Now see the output here. This is called inconsistency output. Run this program. Run this program. Sorry, I have not started now. T1 dot start. Without start method, thread cannot be started. T2
Yeah.
dot start. Yeah, now I can run. Now look at this. What output I got? Booking successful. Your rule number is 102. Booking successful. Your rule number is 101. How many seats actually available? Don't see these last two statements. Actually, how many seats available in our core subject? 1. But how many
1.
bookings are successful? 2.
2.
Tell me, is it a consistent behavior or
Inconsistent.
inconsistent?
Inconsistent.
Inconsistent behavior. How to overcome this problem?
By
By
applying
using synchronization. How do you apply synchronization? By creating synchronized method. Right? If any task that should be executed by only one thread at a time, make the task as synchronized task. How can I make the task as synchronized? By creating that method as synchronized
method.
method.
Synchronized method.
Okay, now I want to make this method what's the keyword I have to use?
Synchronize.
Synchronize. Now see the same example. Let's run this program. Just only what's the one change? I have applied
Yes.
synchronized, correct? Let's
Yes,
run
sir.
this. Let's run this. See guys, what's the output now? Booking successful. Your rule number is 102. Tell me how many bookings successful? 1 booking successful. What are the available seats now? 0.
0.
Error. Sorry, seats are not available. Your rule number is 101. Tell me now, for whom booking is successful, for whom it is error? 102 student,
T1 got
booking
it.
successful. For 101 student, sorry, error. Now tell me, when there is only one seat available, seat is booked for one student only, not for 2.
Yes.
This concept is called what? This is called consistent behavior. To get this
Yes.
consistent behavior, we need to apply what?
Synchronize.
Synchronization. Okay, right. So I will also explain synchronized block and all in further classes. But first I'll copy this example for you today. Please practice this example. This is very important.